and windrowing the materials in place there. So we can even further eliminate a lot of costs and societal and environmental impacts. Future directions, the number one thing would be to increase the recycling that we do and reduce the disposal, what little disposal or stockpiling we're doing right now. Concrete pavement is 100% recyclable, but we know for a fact that less than 100% of concrete debris is being recycled. I think it's quite a bit higher than the 60 to 70% that you see listed here for all concrete debris. That includes building demolition as well as pavements. I think it's a little higher for the concrete side, but I haven't seen those pavement numbers published recently. Our goal obviously is zero waste. And we can also improve the utilization of those products. Best sustainable practice means using them in the highest grade application. A lot of times that means back into concrete mixtures, either in the bottom lift of a two-lift or into a concrete pavement surface by itself. It's been a little while since anyone reported on this, but 15 years ago the USGS reported that 15% of crushed concrete was being used in new concrete mixes and 78% in base and landfill, with the remainder going elsewhere. So we can do better. And I think there are movements and implementation activities underway that will help to make that happen. It's only going to happen through more guidance and training. The CP Tech Center has an initiative underway with Federal Highway Administration to do that. And there's also a lot of existing guidance out there in the form of FHWA tech briefs and policies, industry bulletins like the ACPA bulletin I've mentioned a few times. ASHO specifications and guide specs on the use of crushed concrete in base courses and surface courses, and ACI has a document out there as well. It really deals mostly with building and demolition debris, but it touches on the concrete pavement side as well. So kind of closing things up here, economic and environmental considerations for end of life. Generally accepted that recycling and reuse are the most effective ways to improve pavement sustainability for all types of pavements, but we've got to quantify those effects. The oft-cited example is how transportation costs of recycling can often offset and make recycling less environmentally sustainable than using natural materials that might be available locally. So we've got to look at those things. But the goal, of course, is to come up with this zero-waste highway construction stream, and there's more emphasis on that these days with the importance of incorporating these recycled co-product and waste materials in our pavements, and thereby slowing the depletion of our good natural aggregate sources. Talk about our zero waste closed loop concepts for pavement systems, where we get a significant portion of our energy and materials and water even from the use and reuse of those materials on site, trying to move toward the fat end of this triangle here with the reuse and reduction and even avoidance of disposal in these cases. The potential advantages, oft stated here one more time, keep from generating the waste in the first place, creating opportunities for employment and industry in the recycling applications, new closed loop economies, transforming these industries towards a better use of resources, cleaner production processes, and extending the initial producer's responsibilities for those materials. And that goes back to what Imad was talking about previously with the allocation issues. More economic benefits through the more efficient use of our resources and the conservation of landfill space, which we've talked about also. So that kind of wraps my stuff up, and I'll turn things back to Kurt.
All right, thank you, Mark, and thanks to all of our speakers here today. That does bring us to the question and answer segment of our webinar. We appreciate everyone who's taken the opportunity to submit those questions, and we'll try to get to as many of those as we can before we shut things down here in about 16 or 17 minutes. But if by any chance we don't get to your particular question, or if you have a follow-up question, we would encourage you to submit that question to any of our speakers at their email addresses shown on the screen. So now I'll turn it over to Tom Van Dam, who will begin the question and answer session.
Thanks, Kurt. I'm going to have the first question for Ahmad. Ahmad, it was asked, what kind of tool did you use for calculating the emissions in the LCA data that you were presenting?
You can hear me, Tom, right?
Yes.
Yes, excellent. The tool that we were using is a special tool that we developed here at University of Illinois in collaboration with some partners, and this tool has been developed for part of a project for the tollway. There is some other tools, but this tool is kind of unique, and hopefully we'll be able to present this by the end of this year.
Sounds great. And I'm going to move to Hassan. Basically, Hassan, regarding full depth reclamation, what do you consider to be, maybe the main benefit, and then also, a main limitation?
Thanks, Tom. I think we can for FDR applications, the main benefits, it's obviously the economical savings and environmental savings resulting from not transporting the virgin materials to the job site. And there is clear reduction in the cost and also the environmental impact. As far as the limitation goes, I think performance variability, changing with from site to site, and availability of contractors to be able to do the specialized job, and also another limitation can be considered as traffic opening and curing time, which may affect the environmental impacts as well.
Sounds great. Does anyone else want to add anything to what Hassan may have said, or good enough? All right, no one jumped in. You only have about 0.5 seconds to jump in, then I move on. There was a question directed to me on preservation. It said, what are the typical treatments used today to improve pavement smoothness and noise performance, both for AC and PCC? And I think really, when I'm looking at design now and construction, I think that the basic strategy that for high volume pavements in particular, that rise to the top are where we use like a perpetual pavement design for asphalt, or a long life pavement design for concrete. And then our preservation is really focused in on kind of a global renewal of the surface. And so when we get to the asphalt pavements, I know I mentioned this idea of a micro mill where we can remove fairly carefully, as far as milling goes, 3/4 inch to an inch of surface, and then relay, 3/4 inch to an inch of surface. That therefore you kind of have a good solid structure that all of the distress is isolated to that surface, and now we can, replace it with something like an asphalt rubber friction course, or some kind of open graded surface, which is very quiet, will provide reduced spray, and give you that a good riding, a ride quality. On concrete, really the key is designing and constructing to be diamond ground. And surprisingly, even though we'll remove maybe, let's say, 1/4 inch of surface each diamond grinding, you can diamond grind a concrete pavement 3-4 times even, and that has been done. And so if you have the right structure, you keep the stress simply one of where ride quality is decreasing, maybe due to warping or a little bit of faulting, you can kind of maintain that surface, restore skid resistance, get a quiet surface through diamond grinding. And again, Mark or Kurt or anyone else, did you want to add anything to that?
I think you're spot on there, Tom.
All right. Well, you weren't silent anyway. That's good. And the next question is to you, Mark. I guess the question would be, what major barriers do you see to increasing the amount of material that is recycled? So when you're looking at, recycling concrete, I mean, you talked about this, but what really rises to the top?
Well, that's a loaded question, Tom. I think it's a multifaceted thing.
All right, pick a facet.
Pick a facet. I'm going to pick them all. I got a couple minutes here. I'm going to pick them all. I think really what it all comes down to lack of current experience, and I'm going to talk about this as if it was any particular. I realize it varies from agency to agency, but for any particular DOT that might be considering it, it comes down to lack of current experience and or current specifications. And I think that I mentioned that there was a lot of recycling done back in the a bit done in the 70s and 80s. There's a little bit of a push there, and there were some, we did a survey actually for Federal Highway Administration back in the 80s that looked at how those projects performed. There were over 100 of them around the country at that point, and most of them performed pretty well, but there were a few that performed so poorly as to be noteworthy, and they got a lot of notes taken, and they were widely discussed, and everyone kind of backed away. So there was kind of that bad experience thing that happened, and as a result, the use was stripped out of a lot of specifications or prohibited by specifications. And I think we've recognized now that there are ways to mitigate the problems that were observed back in those early failures, but it doesn't exist in the specifications right now. And you currently see a lot of the DOTs, or you've had a lot of turnover over the last 30, 40 years, obviously. So the institutional knowledge and institutional experience often goes away. And on top of that, everyone's busy. There's not that many people there. And to write a new specification and to develop something new and to get it properly reviewed by people that you trust and have experts available to do takes time. And a lot of folks don't find they have the time unless there's a top-down mandate. So I think a lot of it comes from, in short, it just comes from a lack of current specifications that will allow increased use, or particularly use at higher levels. I will point out that the FHWA, I think it was 2004 survey, indicated that there were like 41 out of the 50 states that are using crushed concrete, for example, in some capacity, and 38 of them were doing it into bases. So we got a lot of folks out there that have it on the books and are able to use it. Maybe they can tweak those specs and use it better, but not many folks are using it back into the higher type applications. So I guess that's really what I'm talking about when I talk about lack of current specifications, going back into concrete materials. The specs aren't there, the experience isn't there, and there's a reluctance to stick your neck out a lot of times, and it's all understandable.
Great, excellent, Mark. And I'm going to move on to a question that just came in for Hassan. The question is, how rough is the ride on fresh FDR, prior to placing the asphalt? In other words, so how rough is it?
Yeah, could be pretty rough. So that's why I think I listed as one of the limitations the traffic opening time for FDR applications, and because of that time elapses after stabilization before placing an overlay or other surfacing options, that's the time that we, I think, have to pay the price by riding on relatively rough surfaces.
Sounds good, and now questions have come in, so this is good. You guys are doing your job out there. This one's for Ahmad. How do you see the future of allocation methods for recycled materials within pavement LCAs? And following up, the current methods help, but they're not correct or the best way that fulfills the requirements. In closed loop recycling, it could work. It works. Well, let me get this right. In closed loop recycling, it could work best, but for an open loop recycling, it could be hard to get agreement on, based on what is available today.
Thanks, Tom. I think that we are going on the right direction now as we are moving forward with LCA. As we are moving with LCA, we'll be able to understand the allocation even better in the future. In order to do the allocation correctly, we need to have the correct calculation. If we don't have the correct numbers at this time, we come up with estimates and we do sensitivity analysis on these estimates, and accordingly we do the allocation. But in order to do that properly, we need to have to be transparent. Sometimes, as maybe the questioner, he mentioned, if you are dealing with the closed loop, that will be easier because the people are from the same industry and they know what's going on. So, I mean, in a way, we are indirectly transparent, even if we are not. But when we are in the open loop, that's going to be a little more tricky, and I think with time it will be more open and more transparent. So I'm optimistic that will not be an issue in the future as we are implementing the LCA. A lot of the information that we will be using for the allocation, it will be a knowledge for everybody at that time. So I think good estimates will be available.
Perfect. So Mark, there was another question that came in for you, and this is an excellent question because it does reflect, not that the others weren't excellent, but this is also excellent. It kind of reflects the trade-offs. It says, does the economical benefit of reusing the concrete for aggregate overcome the increased need for cement to maintain strength?
I don't know that anyone has looked at it that way, but I don't think that there's an inherent assumption there that you need to increase the cement content to get the strength, and that is not necessarily the case. The strength of the concrete is more greatly influenced by, first of all, the quality of the aggregate and hoping we don't have a lot of microfractures there and so forth, that the boundaries on the aggregate are good. But it's really more a matter of the water cementitious ratio and the curing that's done. So I think to assume that more cement is necessary is maybe proceeding from a wrong assumption. If it was determined for a particular application that additional cement was required, obviously the answer is going to depend upon the difference in costs between the crushed concrete and the natural aggregate locally, and those numbers vary quite widely. I mean, I would guess that if you were, I'm going to just hypothetically, downtown Chicago and the nearest quality aggregate source is 50 miles away and you can crush on site, you might be able to pay for an extra 50 pounds of cement per cubic yard pretty easily with the reduced haul distances and stuff. But if you're out in the middle of Iowa and you got a natural quarry down the road that the operator's sitting around doing nothing, maybe you can't. But I would first go back and examine the premise about needing extra cement to achieve the strength, because that may not be true. There are other approaches to achieving strength with recycled mixes.
Excellent, and I think what you said does also, you could change economic to environmental and look at trade-offs of, what it's going to cost to remove material, haul it away, mine new material, and then also add in the environmental impacts of if there were a need for some extra cement. So, I mean, that arithmetic can be done, and likely will be done in the future more so. I have a question for, this one's for Hassan. Is there a technique that you think, for asphalt pavements, and we could probably follow up with Mark on this later for concrete, that's currently being underutilized? In other words, is there, we know we've heard a lot about RAP and other things, but is there something that you feel is really got an opportunity to make a change?
Yeah, I think that's a good question. I would probably say that because we are, I think, very successful in utilizing RAP in various different applications. I don't see any underutilization as far as using RAP. But however, for any other in-place recycling techniques, I think that's the technique probably currently being underutilized. And this technique, the reason because we are really underutilizing in-place recycling technique. This is not necessarily for FDR, but also it can be valid for cold in place or hot in place. Partly because you don't have enough contractors or specialized contractors to be able to do this job, especially for cold in place and FDR, and similarly for a hot in place. And there is some, I think, hesitation in the agencies because of the variability in the performance of these techniques. But we know that when you really select the right payment, right timing, and the right contractor, this in-place recycled projects or jobs can perform as good as their conventional alternatives. That's what I can say for at least in place, and that's probably those are the two techniques I would say, or three techniques that I would say being underutilized.
Perfect. Well, and that actually gets us right where we need to be, because the clock on my computer just struck 12. So Kurt, I'm turning it back over to you.
All right, thank you, Tom. And with that does conclude our webinar presentation for today. I would like to thank our speakers once again, and I hope all the participants found the webinar both interesting and informative. Again, you may contact any of the speakers if you have any follow-up questions, and their email addresses are provided on the screen. And you can also feel free to contact either Gina Ahlstrom or me if you have any general comments on the layout, format, or contents of the webinar. With that, thanks again for your attendance, and we leave you with a reminder for the final webinar event scheduled for September 9th, which will be on the use phase, and we hope to see you then. So long.